pops up and I don't do anything, let me know. All right, what are your questions?
Okay, so shoot, let me pull. Why didn't I have this thing up already? So I just want to clarify. I guess the easy one would be we are. Since it's an imperative language, we wouldn't use the. We would only use E prime expressions for arithmetic evaluation.
We're only using because imperative language side effect expressions can have side effects, and that's because of that pre and post increment decrement operator. So yeah, so you have to use E prime.
Okay, and then we're like really struggling with the pre and post one. So if we define like the block operator where we have the begin and the end.
A block operator, okay,
we can use that to, or I guess I'm asking if we can use that to like in our other rules.
So I'm not exactly sure what that means.
Can we use blocks in our let blocks, I guess?
So I've taught this for a while, so I suspect that so I'm jumping ahead a little bit and reading between the lines, and so I may be wrong about this, but I think you're confusing the interpreter, the language that the semantics is implemented in, and the language that you are implementing. So the language that you're implementing, you've defined the syntax for, and it can have anything under the sun. Well, it can have a bunch of stuff in it, and that has no relationship whatsoever of any kind to the language that we're implementing it in. Now, that being said, in the language that we're doing the implementing, which is SML, or will be SML, it's sort of pseudo SML now, we want to say the kinds of things that happen in your language. So let me give you an example. And if I'm off, if you're sort of asking a slightly different question, or if that isn't what if that wasn't the point of, where you're like wanting clarification. So if you have, let's do this one. So if this shows up in the middle of a Java program and a first semester computer science student that's taking CS1 comes to you and says, can you please explain to me in English what is happening here? So step one, you have to be able to do that. If you can't do that, then that's sort of a prerequisite to this course, right? That you actually do know how all of this stuff works. What we're trying to do is take that understanding, which may be a little bit fuzzy, a little bit informal in places, and make it precise, right? So I want each of you, maybe you can do it in the chat. I want each of you to write what you think happens here when you're explaining it to a CS1 student, right? So I'm taking CS1, I came across this, I have confusion. Please, upperclassmen, explain to me how this works. Share your wisdom with me. So how does this work? What would you explain to that student? Chat here. The statement executes. Okay, after the statement executes, the X value increases by 1. Okay, so that's pretty good. So let's try a little more. So the student says, so what do you mean X value?
Ooh.
The X value, I'm writing increases by 1 after it executes. After it executes, the X value, and let's make this a statement. Let's not put this in an expression right now, because it's more, if it's a statement, this is sort of the more accurate one. Okay, after it, meaning this statement, after this statement executes, the value of X increases by 1. Yes? And now if somebody says, what do you mean value of X? So Mark already did his share, so now it's on the rest of you. That's the benefit of going early.
I was trying something.
I mean, X is basically just, you know, your variable. Like X could be, like it doesn't have to be X. It could be like any variable plus plus, you know, it's just whatever you have assigned to that value.
Agreed. So that's
Like,
generalizing it. Yeah, so that's general. That's another thing too, right? So that's sort of where our BNF stuff comes in. But yes, so agreed. So we could generalize it. Right? Something like this. Yes.
Yeah.
Okay. But what does it mean, the value of, and let's keep it concrete here first, because if we can't do the concrete one, we can't do the general one, right? So if I say, what do you mean X, the value of X, the X value, what does that mean?
The type, where X has a type assigned to it.
So let me see if I can, let's see if we can Google a little bit. Hold on. What is the value of a variable? Yeah. The value of the variable, which is the value the variable name represents, might be categorized as it's a constant, an integer. This looks like it's a well, it says IBM. Okay. Okay. The value of the variable is the value the variable name represents. It might be categorized as follows. Let's see. These are by example. I'd like, what is a variable value example? No, it's not what I want. What is meant by the value of a variable? It is a type, location, and memory. Okay, here we go. Where is this? In a language, what is meant by the value of a variable? A language, in a language like C, okay, so now we're good, right? With L value variables, right? We've used the term L value in our class, right? A variable is a typed location in memory. So it's a location in memory. All right. So we want the wait. Okay, location in memory. All right. Yes. Okay.
Yep.
So
Yeah.
how do I get, we have a vocabulary. This is all just from the lectures. No, gets the location. Accesses a location and updates. So what we're saying here, the location in memory that's associated with X, that's for this variable, that's where the value that X is stored. That value that's there is going to be increased by 1. So that's a prerequisite to this class. We're not discovering that in this class. What we're discovering or practicing is saying this precisely. So if I say, given a model, which is an environment in a store, I can ask it, I can say something like access environment ID M. This will give me, and if I do get location, and there are lectures on this, right? So there's slides, and so I'm just repeating myself here. This will get you the location in memory. Memory where the value associated with the variable ID resides. There. Right, that is like given. That's like, I can show you the slides where we talk about all of this, right?
Are you putting that on a notepad, Professor?
Oh geez, God, I'm sorry, guys. Yeah. You're not following along? Yeah.
Put it in the chat.
Switch, please. I just speak up. Don't be shy. Okay.
I wasn't sure if it was just mine lagging behind.
So here's the thing, right? So we have this. We have this is our English sentence that we told our freshman friend. We polished it up, generalized it a little bit. We then looked up what we Googled a bit, and we found out that this is a value is a location in memory. The bit, you know, what's stored there. And so now we have from our class, this is our stuff. We have these functions. They're not English, but I can use those to define computations by stringing them together. So I can, for example, say, get, and this is again from slides in class, right? It says, get the location. So this will be a the location. So this is kind of like the notation that we do in class. This gets us the location associated with, you know, if ID is X and it's stored in location 27 and 27 has the number 5 in it, this gets me location 27. Then if I say this gets me 5. So here, this is where, like, let's say x equals 5, right? That's what's stored in memory. This gets me the memory location. And this gets me the contents of that memory location. So this would get me 5 in this example. So I have the value of x now. And we're saying that after we execute this value is increased by 1. Well, I can do something like update store where location, what value, and M. So now the stuff that I'm writing right here, these are not parse trees. This is program, this is code in the functional programming language SML. We're not doing exactly SML right now, so think math, right? But I'm trying to make it as close to SML without getting all picky about syntax. But it's very, very close to what we're doing is very, very close to SML right now, okay? So think of, could I write something like this in Java? If you can, then you can write it here. Kind of like that, right? So now I have ID now, ID value is now increased by 1. Ooh, sorry. Now increased by 1, yes? And so if somebody says, what does it mean? Hold on. Why is it doing this to me? All right, and I'm cleaning this up. Make it a little bit more readable, you know, all that kind of stuff. So this is to us how we say, this is the meaning of ID++ as a statement to us. And then we say like, well, how do we connect this to the grammar? And we say, well, we have, since it's a statement, and remember, we're making a sharp distinction between statements and expressions. Statements are evaluated using this function called M that we're inventing. And expressions are evaluated using a function E prime. So M gets a parse expression. You know, whatever your grammar, and from this I can do a reverse engineering. But basically, let's just say, where's my nothing? Let's just say, let's just say that is in our grammar.
Okay.
This thing is now going to define this tree. And I'm going to give it the current state of the program, which is M. Well, let's call it M0. The current state of the program. And I'm going to say, hey, when you see that, hold on. Oh, it doesn't. Oh, this is Notepad. Oh man. All right. Wait. All right. So can't do. Okay. And let me clean this up a little bit here. So what this is saying, it's saying this, but if I'm going to translate it from here to English, I'm going to say to execute a statement that is ID++, this is what you do. Step 1, get the location that's associated with that identifier. Then get the value that's in that location. Then add 1 to that value and store that back in the location that was associated with that identifier. And that's the new program state that gets returned. Done. So I have, you know, obviously there's a lot of lectures on how to do all of this stuff and a lot of examples. And so, but this is the idea, right? Is that try to figure out how to say it as precisely as you can in English. Google, if you're like kind of struggling for like, you know, what do you mean memory? What does it mean to say value in a programming language? You know, the value of a variable. We have the world's largest library at our fingertips. So Google around for that, right? Until you find something that looks reasonable. And then say like, okay, memory, okay, this is starting to, I can start mapping this onto this, the formal stuff that we have in this class, right? And then you say it that way, and you should be able to read it back, right? You should, it's important to connect it, to connect the symbolic math part of your brain with your speaking part of your brain. It's like immensely important, actually, to be honest. So it's good practice. And if you can't say it, maybe the idea is not clear or you don't quite understand it, right? So practice saying it, right? Because all that this says is get the location in memory that's where the value that's associated with this identifier is stored. And then we get this location. And then we say, okay, go to that location in the store and find out what that value is. Okay, it's this. I could, if you wanted to make this more English, right? New V. Or updated V or whatever you want to call it, right? And say next, let new V, right in math, you say let X equal. That's where this let comes from, right? It's inspired by math. So let new V be V plus 1. Update the store at that location with new V. That changes, that's going to change the store. So now we have a new model of our state of computation, and that's what we're going to return. So ta-da, we have now executed that. Good.
Yep. I'm trying to think. I guess the difference is for like the pre-increment, what I'm looking to do. I don't know. It's hard to see since we're only incrementing one statement. It's hard to see what the difference would be.
From at the statement level, there is no difference.
Yeah.
There is nothing that you can do. No print statement, no instrumentation you can do that has that be different. If you were a hardware person, you instrumented when things happened, but the idea is that it matters in an expression, right?
Yep.
When you have an expression, now it matters. But that's an expression. So that's a different, when this gets executed as an expression is a different critter, slightly. And there, pre and post give you different stuff. Right. So that is, but what we didn't do that example, we did this example. Right. And so similarly, right, variables are very different depending on where they show up. The variable over here is an L value. The variable over here is an R value. Which I talk about in class, right? So this is I'm not telling you new stuff now.
Yep.
Okay. So depending on where you are, your semantics may be slightly different for stuff. And that's okay, right? And so the thing is to just figure out what it is, and then figure out a way to say it like this.
Okay. So for our group project, we're just making the every rule we had in our milestone 1 into a parsed expression and then defining each parsed expression. That's what I'm understanding.
Yeah, you're doing one of these. So for all of your statements, you're going to do an M something. All of your statements kind of start out like this, where the only part that would be different would be, here. And then all of your expressions are going to be E or E prime. It's E prime from the lectures, but you can call it E just as long as you know in your head that, there's a signature, right? This thing takes a parse expression and it takes a model and it returns a tuple, which is a value and a model. Where M takes a parse expression, takes a parse expression and a model and returns a model. So these are different critters, right? And these are signatures just like Java has signatures for its methods, right? There's nothing like exotic or new about any of this stuff. You should feel fairly comfortable reading these kinds of signatures as long as they're not too crazy. You know what I mean?
Mhm.
And
Yep.
so what this means, right, is that I'm just going to give you a little help here. M in all cases always returns only a little m. This always in all cases will return a tuple. So, people sometimes get confused and sometimes they have E return one thing and then sometimes return something else. And it doesn't work like that, right? Think of it as one function. When we implement it, it'll be one function. So it's whatever that type, whatever the thing is that it returns, that's what it returns always. In Java, right, there would be a function E and its body would be a giant switch statement, kind of. Where it says if you're this, 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 and then return. And this thing is the same thing. So that's kind of how it would look in Java. So don't mix and match. Don't arbitrarily start changing things, right? Sometimes you return one thing, sometimes you return something else, because that's automatically not right. It won't work, right? All right. I have another meeting in a couple of minutes, but do you have any last questions? Anything last?
I guess I was for the for loop. It was our expression with like our start block and our end block around our while loop, kind of like you talked about in class, but like we'd would define that, or if we said begin or end, is that like acceptable?
In English, right? If we go to, I'll just walk you through this, right? It's, let's see, where am I here? In English, if I do Java for loop, and I go here, I'm going to say, my young CS1 student, my freshman, to execute a for loop, you do the following. You execute the initialization. Then you evaluate the termination condition. If it's true, as long as this is true, you're going to keep going. You evaluate the body, and then you evaluate this part in that order. So you evaluate this, then you evaluate this. If it's true, that means you got to evaluate the body. So maybe termination is a weird, somewhat misleading name, I think, right? It's a continuation. Should you continue? If should you continue is true, then you evaluate the body. And then when you're done evaluating the body, you evaluate this, and then you cycle here. You do this again, this, like that. So that's how you do it. So you need to say that in, given the functions and stuff that we have. A lot of the other stuff I've given, right, just so that you know. So there's only a few that you actually have to, really figure out. Plus, maybe shifting things into your notation a little bit. And on that note, I have to go. Any one last thing I can do, like one more sentence?
No, that's fine. Thank you so much.
Okay.
Thank you for your time.
You're
Thank you.
welcome. You're welcome. Take care.
All right.